Let's start with the structure of the adult heart. As you know, the heart is a pump, but more correctly it's two pumps, one pumping blood from the body to the lungs to be oxygenated, and the other pumping the oxygenated blood back to the body via the aorta. Now let's think about the fetal heart, which is essentially only one pump because the baby's lungs are offline. We're going to start at day 22 of development. By this point the heart tube is formed, and as you can see it is a relatively basic structure. Blood from the yolk sac, the placenta and the body of the embryo enters the sinus venosus at the caudal end of the heart tube and passes out through the aortic roots at the cranial end. At 23 days, the heart tube starts to fold and loop due to differential growth. The cephalic end bends to the right and moves ventrally and caudally relative to the sinus venosus, which moves cephalad and dorsally. The folding of the heart tube takes place over only 6 days, so by day 28 the heart tube has the configuration that we see here. It will also have increased in size. By day 28, blood flows into a common atrium, then through a narrow atrioventricular canal into the primitive left ventricle. From here, blood flows through an interventricular foramen to the primitive right ventricle and out through the bulbus cordis, which consists of the conus cordis and truncus arteriosus. A frontal section through the ventricle gives a clearer picture of what's going on. The heart has two primitive chambers connected by a common atrioventricular canal. During week 4 of development, endocardial cushions develop superiorly and inferiorly, which divide the canal into separate right and left atrioventricular orifices. This cross-section shows the two chambers, a common atrium and a common ventricle, with the fused endocardial cushions dividing the atrioventricular orifices into left and right. We're now ready to discuss the two septa which need to form in order to separate these into two atria and two ventricles. We'll start with the atrial septum. Two views are shown. The insert shows the view if you were inside the future right atrium looking towards the midline. The purple plasticine represents the septum primum, or first wall, which grows down from the roof of the common atrium. The gap at the bottom allows blood to flow from right to left and is called the ostium primum. Before the septum primum completely blocks off the flow of blood between the atria, a second hole forms higher up in the septum called the ostium secundum. A second wall starts to grow down from the roof of the atrium, shown here in blue. This is the septum secundum, the second wall. During fetal life, these septa create a shunt for blood to flow from right to left atrium so that it can bypass the lungs. This opening is called the foramen ovale. After birth, the pressure in the left side of the heart is greater than that in the right. This causes the septum primum to push against the septum secundum. They then fuse together, leaving an indentation seen in the right atrium called the fossa ovalis. Failure of any part of this process can lead to an atrial septal defect. Let's play that back to see what's happening to the ventricles. A muscular septum grows up to form the interventricular septum, separating the ventricle into left and right. Endocardial cushions also grow in from the sides between atria and ventricles. The final part of this septum is called the membranous part and develops from a different source. Let's take a frontal section again to look at the ventricle and bulbus cordis. In this view you can see lots happening at once. The atrioventricular canal is dividing as we saw earlier, and a spiral septum is forming in the outflow tract, which contributes to the membranous part of the interventricular septum. Failure of this membranous part to form can cause a ventricular septal defect. Now let's go back to discuss that helical septum in more detail. The adult heart has two outflowing vessels, the aorta and the pulmonary trunk, which spiral around each other in a strong and compact configuration. So a third septum must develop to separate the original single outflow tract into these two vessels. This schematic model shows ridges forming in the walls of the truncus arteriosus and conus cordis during week 5 of development. Over the next week or so they fuse, forming one spiralling septum, which divides the outflow tract into the pulmonary trunk and aorta. If these ridges fail to form correctly, transposition of the great vessels can occur. So by the end of week 7, we have the heart structure which will persist for the rest of the embryo's intrauterine life. Blood drains into the right atrium, most of which passes through the foramen ovale into the left atrium and out through the left ventricle into the aorta. Blood which passes into the pulmonary circulation is redirected into the systemic circulation by the ductus arteriosus. These two shunts help to bypass the pulmonary circulation, and both close up after birth to leave remnants called the fossa ovalis and ligamentum arteriosum.